What's up, guys? We are back with another year of Advent of Code. So I thought about making a separate video for this, but I'll just go ahead and tie it together into the first day video. What you can see on the screen right here is the script I use to fetch the input files and just set up my environment basically for each day's challenge. So this year I'm doing the challenges in awk. I just finished reading the awk programming language, second edition. And I highly recommend it. It's a great book. Awk is a really powerful little scripting language that's just a lot of fun to write, in my opinion. So you'll see this is just a little shell script I've got written here. We define some variables here at the top. We set the year. We get the day with the date command. Then we have a directory. And then we've got the URL for Advent of Code, the year, the day. And then whatever day it is, I'm just going to have a main.awk file. That's what I'll be writing the code in. I open Advent of Code for that day in Brave, the web browser I use, make the directory, and then probably the most exciting lines are right here. So you can use curl with the -- cookie flag and a cookie file to provide your Advent of Code cookie. And then you can just curl your input directly and pipe it into a file. Now, if you read the documentation or read the man page for curl, you'll see that it can either take the cookie at the command line or it can take a cookie file. But I have yet to be able to work out the actual format for the cookie file to be read as a file. So I'm just using a little bit of process substitution here in bash to cat out my cookie, and then curl treats it in the command line format. This line right here is using the xclip program to basically paste my primary selection into, you see -o for output, and we put that into dir/sample. So selection primary means I just have to select the sample from the Advent of Code website. Then I come over here, run my script, and it curls the main input and basically pastes my clipboard into a file. And then last thing we do, we just echo a nice shebang line into my source file, make it executable, and then open it in Emacs. And then I can compile it and run it like usual. Okay, so moving on to the first day's challenge. So what I'm showing here is just the sample input file. And I'm not going to read you the story or anything. If you're interested, I'm sure you've already seen it, or you can go find it yourself. But the challenge for today is to take each of these lines and extract the first and the last number from each of them. And then you combine those two digits into a number, and that's the result that you add up on each line. So in this case, we would get 12. In this case, you get a 3 and an 8. And then this is one of the interesting cases where there's only one digit. So that is both the first and the last digit. And I mean, just for completeness, I guess this is 1, 5. And if you add up those numbers, that's your result. So let me undo that. And then we'll hop over to the actual awk file. So I probably should have hidden this. So we can ignore all of this for now. Basically, that's going to come into play in part 2. And focus in just first on this fs equals double quotes. But I guess we'll take a quick step back even from that and talk just a little bit about how awk works in general, for those of you who don't know, because it is the first day. So what you should think of when you read awk or write awk is always think about a pattern and an action. So that's actually what we see in the very first line. We've got begin, which is a special action that runs when the program starts up. And everything inside of curly braces is the corresponding action. So you can think of this at the beginning of the program, run this code. And in awk, you can either separate lines, like logical lines, I guess statements or expressions, with semicolons or with actual new lines. So in this case, just to be really short, I separated fs equals this and part 2 equals this with a semicolon. Now, awk is really used a lot of the time for kind of command line processing. You would write like a shell one-liner in awk. So it has these kind of special variables built in that lets you control a lot of its behavior. So this fs right here is the field separator variable which defaults to any white space. So if you've ever seen awk used on the command line, you may have seen something like this. Awk print $2, for example, will print just the second column. So this was the original use I saw for awk, where maybe you grep out some pattern, and then you're looking for a field to extract, or you're looking for a program to extract one specific field of a line. So that's how I first encountered awk. I assume that's where a lot of people find it first too. But you can change the field separator from white space to anything you want. And what I'm doing here, because we need to look through each of the characters in the line, I'm making the field separator empty. So now each character in the line will be its own field. And what's convenient about that is that you can access fields in awk using $, and a number. So $1 is the first field, $2 is the second field, and so on. There's another special variable called NF, which stands for number of fields in a record. So that is the last one in the line. So I know I told you ignore is number for now. We'll come back to that in part 2. And we can just start looking at the part 1 solution. Actually, this stuff is part 1 as well, or part 2 as well. So we can jump straight down where I was talking about NF. So because I defined the field split character, or the field separator to be nothing, each of the fields, $I, so we've got a C-styled for loop where we start I equals 1. Important to note, awk arrays and stuff don't start from $0, because the field $0 is the whole line. So we start at $1 for the first character. So for I equals 1 to the number of fields, increment I. And really all we needed for the first part was this part of the if right here. So if I matches a number, so this is kind of like Perl's regular expression match. You got your tilde, and then in here we've got a regular expression. So if I matches a digit, basically, then we store that digit in this numbers associative array. So this is, again, awk is used for command line scripts. So a lot of things happen without any kind of initialization. So I didn't have to create nums somewhere or anything like that. As soon as I use it, it just springs into existence with like an empty value. So I just say nums, and then I index it with length or len, which is a variable that springs into existence when I first use it as well. And so it'll initially have the value of 0. So I just stuff each of these digits into here, and then at the end of the line, I can assign, I can concatenate the digits. So at this point, right, I've put, let me pull up the sample. So for line 1, for example, when I'm in $1, I'll get 1, and I'll stick that in nums of 0. And then I'll go to $2, $3, $4, finally $5 or $NF. I'll find the 2. So I'll say nums of 1 equals 2. And again, yeah, ignore the buff stuff. That'll come into play for part 2. Once I finish the loop, again, I've got numbers. It's got a 1 and a 2 in it. So I take the first element and I take the last element. So because I'm using the postfix increment operator, len at the end will actually be 1 greater than the indices in nums. So we just do len minus 1. And one of the funny things about awk is that when you do string concatenation, there's no explicit operator for it. You just put things next to each other. So I think this actually works even without this. I added this probably when I was debugging, but that's all you have to do. You have 2 strings, you put them next to each other, they get put together. So there you go. And then our goal is actually, so I couldn't think of a very good name here. I just called it tot. That's the total for the line. And then the total sum is called sum. So we add the tot for the line to sum. And then like there's a begin block, there's also an end block that runs at the very end of the program. And inside of there, we just print sum. So let me set part 2 to 0, which means false, just like in C. And I can run this. Let's do compile. oh, that's some stuff for work. We'll just do main.awk on, we'll do input 53080. I believe that is the correct answer. That is the correct answer. Just double checked. And then we're ready to move on to talking about part 2. So the main difference in part 2, we can switch back to our sample. Actually, we better look at sample 2. In part 2, we realize that not only can there be numbers, but there can actually be numbers written out in letters. So that adds a surprising amount of complexity, especially for me, because when I ran my code on the sample, I ran into some problems with my first approach of trying to use like a regular expression to just replace each of them. Because if you do it that way, the order in which you replace the numbers interacts with the remaining numbers. So I rewrote it in this way where I'm using a buffer where I accumulate letters until they match one of the numbers. But even when I was doing that, I thought implicitly in the sample that we were supposed to ignore overlapping matches. So for example, when I saw 2, 1, I thought that the leftmost match would take precedence. But in fact, to get the right answer, you have to treat this as both 2 and 1. In this example, this doesn't actually matter because all of the overlaps are in the middle. But if you have an overlap at one of the ends, one of the numbers that you're actually trying to add up, this will cause problems. And I think that usually comes up in everybody's inputs. So I actually, like I say in my repo for this year's challenges, I didn't actually figure this one out by myself. I tried to debug it for like 30 minutes. And then I went to Reddit and looked for a hint because I just could not figure out why I wasn't getting the right answer. But anyway, let's talk a little bit about the solution to part 2. So I guess, sure, we can start with this isNumber function because it's pretty straightforward. So I'm going to be passing in some string. I usually call things like this buffers, so I named it B. And you can do this matching operator we talked about before on variables or on fields like before. So all I'm doing here is if our string matches the word 1, then you give back a 1, a 2, 3, 4, 5, 6, 7, 8, 9, and so on. However, to handle the overlapping matches, I also use this index function, which is built in, to find where in the string this occurs. And then I set this global variable index to it so that I can use it down here. Because what I'm doing here is I'm just advancing my buffer. Before, when I called isNumber and it was a number, I would just reset the buffer. And so this doesn't handle overlapping cases. But if instead you just trim off the first character where the match begins in your buffer, then it will no longer match the previous number, but it will leave all of the other characters for further matches. So that was kind of the key insight I needed to get my code to work. So now we're ready to talk about this. So I initialize. Again, you don't actually have to do this necessarily. Let's put this back to part 1. I mean, you do have to do this either at the top or the bottom, but you don't have to initialize variables. But anyway, so we initialize our buffer, which is going to hold our strings as we build them up. We initialize length to 0. We have the same loop as before. Almost the same if as before, but again, we didn't need the buffer part 1, but we have to reset our buffer as soon as we find a number. Because we know that the number is not going to be part of the sequence. So the other case here, if it's not a number, then really this can just be an else, but I put else if part 2, just so that I can still run the part 1 example. And again, we're using our string concatenation, so again, $i is just one of the characters in the input, and buff is the buffer we're building up, so we're just pushing I onto the buffer. Because I need to use this later, I assign the output of the function to it, and if it is a number, we put it into our nums array, just like we did up here. And then, as I was saying, we use index +1 to move our buffer, basically, um, and handle overlapping matches. Otherwise, it's pretty much the same. And I actually just ran this while I was checking if I had to reset length, and that should be the right answer. There we go. So I hope you guys enjoyed that. Stay tuned. I'll be making videos for at least as long as I can actually solve the challenges myself. So thanks for watching, and see you guys next time.